Welcome back, everybody. Today is week 3, day 4, and I'm again joined by our fantastic second grade teacher, Miss Stubbs. And so today for our announcements, Coach Fryer is doing a special tour with us to show us a place in the school that you have never been. So let's go ahead and cut over to Coach Fryer now so he can show us something new. Coach, take it away.
Hey everybody, how's it going? Good to see you again. Coach Fryer here. Today for our morning announcements, I wanted to give you guys a tour of inside our book truck. As you know, most of the time we send you guys books, we do it on our iPads and stuff, but I don't know if you guys knew this, we actually have to have a copy of all those books in our book truck just so that we don't get in trouble from anybody for copyright reasons. So I'm gonna take you guys inside there today and you're gonna see what's going on. So let's do that now. All right, got a handy dandy ladder here. All right, so as you can see,
Oh, wait for me, Coach.
Oh, sorry about that.
Sorry,
As we're
a little slow.
as we're hopping in the truck here, we got all our textbooks against this back wall. So anything you guys have on your iPad, if you guys have it there, we have it here somewhere. As we're moving around to the rest of the truck, you can see lots of other, I think we call them readers, I guess, for different grade levels. So let's see, around here looks like some middle school readers, maybe 4th, 5th grade. See Harry Potter, that's always a good one. If we keep going down, it gets a little bit younger down here. So let's see, we got some cool stuff down here. Let's see, wildlife in the Southwest. All right, might be some interesting information for you 1st, 2nd, 3rd graders. All right, and then if we keep going down, we even got some stuff for you kindergartners. All right, 1 by 1, Garth's Pig Rain Song. Looks like a good book to me.
Do you want to take us up to the loft?
Yeah, let's do it. All right, so we got this cool set of stairs that George built us. All right, so we're gonna hop up here to the top of the loft. All right, up here is where we keep all our books that we're gonna read as a class. So let's say Mr. Roll wanted you guys to read The Pearl. We have enough copies over here for at least a small group of you guys to be able to read that and then do your reports on them. Just like other books over here, like, let's see, The Book Thief, Hatchet, that's a great one. I know Miss Kimmy's doing that one. The Bronze Bow, all some really cool stuff.
All right. Hey, well, Coach Fryer, thank you so much for taking us on a tour of the book truck today.
No problem,
We appreciate you showing us everything that's happening around the school while everybody's out.
See you soon.
The truck is looking awesome, and there's all kinds of good resources in there. Super exciting.
I completely agree, Ms. Stubbs. That truck is it doesn't look like it'd be housing a bunch of books when you look at the outside. Yeah.
Totally.
Yeah, I especially like the little loft area up
Yes.
there. Yeah. At first when I saw it, I was like, is this dangerous? But now it's kind of like fun, and kids are not allowed to go in there. So sorry. But yeah, it's a cool place.
Yeah, great.
All right. Well, it's time for our joke of the day. Ms. Stubbs, take it away.
All right. 2 pickles fell out of a jar onto the floor. What did one say to the other?
2 pickles fell out of a jar and onto the floor. What did one pickle say to the other? I don't know.
Deal with it.
Deal with it, because they're dill pickles. Yeah. That's cute. That's a good one. I like that. I guess that could be for any pickle's sake. Anyway, that's cool. All right. Well, ladies and gentlemen, let's go ahead and let's get to our pledge. So if you'd all stand at attention and put your right hand over your heart. Miss Stubbs, take it away.
Okay. I pledge
Pledge
allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All right, thank you so much for joining us, Miss Stubbs. And kids, I hope you have a great day here in week 3, day 4. See you on the internet. Today is day number 3, week number 3, day number 4. And I'm glad that you're joining me here. My days are pretty much full of work. I do business stuff all day. I do family stuff all day. And then at nighttime, I'm able to take some time out of my schedule and do these lessons. And I look forward to talking with you guys and doing these lessons all day. And in fact, I got a new little thing on my desk I wanted to show you. So I found this old cup I bought, and it's for one of my nerdy favorite television shows. It's called Doctor Who, and this is Doctor Who's telephone box. And the cup was way too big for any kind of beverage, so I reorganized my desk. I put all my pens and stuff in it. So, yeah, but keeping busy over here, and looking forward to talking with you today. So, let's go ahead and get into the schedule for today. Week 3, day 4, I decided to simplify it, just keep it simple. Social studies, of course, we have current events. We're talking about economics, and we're in the Reconstruction era of history, okay? Science, we are going over Newton's laws, and in math, group number 1, we're talking about irregular shapes today and finding the area of irregular shapes. And group number 2, we are playing catch up, and then we're doing Khan Academy with solving systems of equations, just to make sure you got it, just to make sure that you know it super duper well. So, without further ado, let's go ahead and let's talk about our economics and current events. So before I flip over to this split screen view, most of you are going to be watching this on either Thursday the 9th or Friday the 10th of April 2020. And the current events outlook is not always great. Here in the United States, we just crossed a threshold where we have like the most COVID-19 deaths in a day. I think, what is it? Something like over almost 2,000 people a day are dying in the United States, or something like that. I don't remember. It's very, very sad. And the news about COVID is changing so quickly that I really don't want to focus on it. Like, for those of you in my class, we talked a lot about COVID-19 before the lockdown hit, because I could see that it was coming, and I could see that it was going to affect all of our lives, and so it was important that you understood what it was and what it isn't, and it's important that you know that you really do need to stay at home to flatten this curve, and so we talked about that then. But things are changing so fast with that it makes more sense for us to talk about economics, so that once COVID-19 is gone and we're entering the recovery phase, you kind of have an idea in the back of your head as you're going through high school and then eventually graduating high school and joining the workforce or going to some kind of secondary education. You kind of understand what's happening a little bit. When people start using some business terms, you know loosely what those terms mean. And so that's why I think this current events talk is more important for your future, rather than just talking about how many people are dying and how many people are getting sick, which is very sad, but again, you get that from just watching the news. So let's go ahead and jump into it. Let me take this down here. So, all right, we left off here yesterday, and I'm going to try not to squeak in my chair. Very comfortable chair, just very loud. Quick review. Okay, we'd already covered this a day and a day ago and the day before that. Okay, you see over there that America makes up 1/4 of the world's economy. Very cool. That's good for us. Everybody else that's not America, China, Europe, or Japan makes up about 1/3, a little bit less than 1/3. So America is really important in terms of our slice of this pie here. You take us out, and the world loses a lot. So, all right. So because the American economy is so big, what is the American economy made of? Well, most of it is made of us. Okay, the biggest chunk of the American economy right here is consumer spending. Okay, so this little bit right here is again what you and I spend. These are things, these are purchases. The big one, when you or your parents or whatever buy a house, that's a huge expense. When you go to the store and you buy groceries, when you go to the gas station and fill up your car, that's all of this. Okay, that's all the blue right there. The green right here is government spending. Again, schools like Da Vinci Tree. Okay, universities, fire departments, police, all of that good stuff. Okay. Right here, whoops, I didn't mean to move the whole thing. Okay, this private investment, this is business. Okay, so if Tatiana grows up and starts her own restaurant because she wants to be a chef, anything that she spends on the restaurant or for the restaurant, all of her ingredients, all of her tablecloths, all of that good stuff, that is in this little orangey yellow area right here. okay? Now, it's important to understand that the way this looks right here, okay, this chart right there is the way it looked in 2019. Now, the way it looked in 2019 is not the way that it always has been. And after the coronavirus here, it may not be the way that it will look in just a few years. And so it's important to understand that dynamic and that change. Okay, I can tell you for a fact that, again, if you're watching this in April or May of 2020, this blue part right here, this blue part for this quarter at least, or for the time being, like right now, this blue part has shrunk. Okay, this blue part of the graph has probably shrunk by a third. Okay, so right now, consumer spending is way down in the United States, but the reason why the stock market hasn't completely just tanked and everybody's not, going into a tailspin is this green part, right? And so the consumer economy has completely gone away, hasn't completely gone away, but is shrinking, is contracting extremely fast. But this green part of the graph right there, the government spending, the government has spent a tremendous amount of money and is doing everything it can to kind of fill in the gap where the consumer spending and the normal private investment or business spending has fallen off. Okay. Now, I wanted to actually take a look because a lot of our classes is me talking. And so I know in the past some people have said, well, Mr. Roll knows a lot, but he's not always right. So, it's not as useful as if you're just reading a book. Now, that's a fair criticism, okay? For our current events talk right now, though, talking about economics, when I tell you things were really different in the past, I want you to see how they were different in the past. And so for me, this kind of stuff is fun because I'm a big business nerd. I was a business consultant before starting Da Vinci Tree. And so I take great pride and great joy in taking a look at this stuff. So here are some figures right here. And these are not Mr. Roll's figures. These come from the St. Louis Fed. Okay, so this is the Federal Reserve Bank of St. Louis. They actually publish data that goes back to shortly after World War II. And so we can see what that looks like. Okay, I want to start off with net exports. So yesterday we talked about how exports in America are actually a drag on our economy. America imports way more stuff than we export. Now, if we look at the graph over here, okay, starting back in the 1940s, okay, right after World War II, all of the developed countries in the world they all had collapsed. The United States of America was really the only developed modern country in the entire world that wasn't completely wrecked. Okay, everybody else was just bombed out and really in the depths of despair. And so the United States of America became the world's factory. And so America was churning out all of the world's manufactured goods, like all the refrigerators, a lot of the cars, okay, all of the office supplies and things like that. And so right after World War II, you see up here that a large portion of our economy is based off of exports. But after World War II, the United States didn't want to just hog it and be just the only country in the world that was nice, okay? So the United States spent a lot of money rebuilding Europe, Western Europe in particular, and countries like Japan, okay? And so as the United States built up Europe and Japan, okay, we see that the exports go down. Boom, okay, boom, 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 it's going down. Now we're still exporting quite a bit, okay, all the way through the 50s, okay, and then in the 60s. Now in 1972, something really important happened. A guy named Richard Nixon, he was the president, he went to China and he met with Mao Zedong, the leader of China, okay, and he, for the first time, made political ties with China, and slowly, China started taking over as the world's main factory, okay? And America started buying our oil from places in the Middle East, and that was an import. And we started buying our toys and our other consumer goods from places like China. And so America started buying the stuff from everybody else in the 70s, really. And we stopped sending as much stuff out overseas. And you can see that change right here. It really, 1976 was kind of like where it ended, and we started really seeing America mostly buying stuff from overseas, importing more than we export. And we had a brief jump over here in the 80s. But ever since then, America has purchased more from other countries by importing than we have sold to them. And so you see this is called a trade deficit. So this is the United States buying more from other people than we're selling to them, okay? And so that's where we get the import and export, and that's why, like we talked about yesterday, we don't include exports as a GDP positive. Exports are actually GDP negative because we spend more of our GDP on buying stuff from other people, and we don't export as much. All right, let's take a look. This right here is what the government spends, okay? And so right after World War II, during World War II, the American government was spending giant gobs of money on military aircraft and planes, weapons and uniforms and training camps and things like that, right? And so after World War II, all of a sudden, we didn't have to spend all that money anymore. And so, boom, you see, like right into 47 and 48, government spending takes a nosedive right there, okay? Now, as all of the soldiers and other people came back to the United States and they started families and stuff, the United States of America started something called the GI Bill, where returning soldiers, we get a free college education, which is great. And so all of these soldiers went back to college, and then in the early 50s, we got in another war. We got in the Korean War. And so you see in the 1950s, it starts to go up again, okay? And so we had a bit more spending here, it dips down, and then it really starts taking off, okay? And so between 1950 and 1953, we had the Korean War. And so you can see right here during the Korean War, we're spending quite a bit. This is government spending, okay? After the Korean War kind of subsides, it ends, and North Korea becomes this evil empire that we couldn't beat, and then South Korea becomes the nice place where we get like Samsung TVs from, okay? After the Korean War, government spending can go down a little bit again. And so government spending kind of goes up and down all this time, and we could talk about the reasons, but it would take too much time. But suffice to say that government spending, again, goes up and down, up and down, up and down. Now, if you look right here, okay, right into 2000, going into 2001, okay, we do see a spike in 2001, and it kind of stays higher, right? And that's because of we had terrorist attacks in 2001, and so everything on here changes with the terrorist attacks. And so we see that American government spending goes up a little bit because we start engaging in Iraq and Afghanistan. And then right here, before the Great Recession, okay, right as America is entering this Great Recession in 2007, we are actually hitting a point in time where America could fall into a Great Depression. It's almost like right now, okay? Like today, the government's spending a lot of money to keep us from going into depression. And in 2007, it wasn't the same way. So if we look at 2007 here, okay, right as we hit around 2007, boom, the government spending goes really high. For 2007 to 2009, the government's spending giant globs of money to try to keep the American people out of depression, okay? And then after we start recovering from that recession, okay, and the American businesses are picking up, the economy's doing well, the government can kind of ease back down on government spending, okay? Now, if this chart, if we fast forward it into the future, okay, and we could see what this chart looks like today, you would see another giant spike at the end there, okay, for government spending. All right, private investment, so this is business investment, okay? And so business investment is really, has this giant ups and downs. It's very, what we call volatile. It's not very stable. Businesses just kind of invest, and then they don't invest, they invest, and they don't invest. And there are many different reasons for it. Again, not the thing that we can really get into today. You do see some interesting trends, though, okay? Like we were just talking about the Great Recession in 2007. And so right around 2007, you see business investment, and it's like it falls off a cliff. Whew, just bam, oh my gosh, okay? Business investment just craters. It's just awful, okay? And then slowly, it comes back, all right? And so, again, there are reasons for all of these things. It's a little bit too much for us to get into for all of them. Lastly, let's talk about consumer spending, okay? And so, guys, like if we look right here, today, consumer spending is about 70% of the American economy. But again, it wasn't always like that. If you go back to the 60s, around here, it was in the 1960s, you know, we were trending around 58 to 60% of the American economy. So it was closer to half rather than like 2/3 or even 3/4. Okay, and so again, you know, we see that the economy has not always relied so much on consumers, just like you and me, to do all of this spending. Okay, all right. So if you're walking away from today's lesson and you're just like, wow, Mr. Roll, everything he just said, went right over my head. I didn't understand any of that. What I want you to walk away with from this video right now is that the way it is today, okay, this chart right here is the way it is today. The way it is today is not the way that it's always been. And it's not the way that it will be moving forward, because life is all about change. And we were different in the past, and we will be different in the future, and that's okay. And it's okay to know that, again, because of the stress that we're going under right now, this is going to change, and we will find our new normal, and everybody's going to be okay. This is not the end of the world. Life is good, and we're going to find our way. Everything's going to be all right, guys. So that's it for current events for today. U.S. history was recorded at a different time, so I'm going to skip over to that video right now. All right, ladies and gentlemen, it's U.S. history, week 3, day number 4. So yesterday we talked about the 13th Amendment on Khan Academy. We also went over what it was like to be an African American who was once a slave and then was let free, and kind of what changed in their life and whatnot. And then we also talked about the black codes, these terrible, terrible laws that were extremely discriminatory towards African American people. I want to add something because this was recently in the news about this Reconstruction period of time. As it turns out, there were actually people who were slaves during the Civil War, African American people who were slaves during the Civil War, that lived all the way up until the 1950s, and so. This research was just released because, believe it or not, but people who were slaves, their birth dates and birth certificates and stuff, they weren't super accurate and they weren't very well documented. But we've discovered that that people who survived slavery actually lived all the way up until after World War II. So it is actually within living memory. So there are people alive today who were friends with people who survived slavery, if you can believe that. That just blew my mind that in 2020, somebody who is currently alive today could have had an interaction with a former slave from all the way back then. Wow, that's amazing. All right, so for today's lessons, the first thing that we're going to be talking about today on the Khan Academy lessons is the Ku Klux Klan. The Ku Klux Klan, or KKK, is a absolutely miserable, horrible, awful, racist, violent group of white people whose sole mission in life was to torture, torment, and kill African American people in order to keep them cowed and scared in the South so that white people could reign supreme. Okay? Now, the KKK originally started with a nice euphemism or a nice name. They called themselves a social club. Okay? Oh, my wife Margaret has a social club where they go and play bridge and other card games twice a week. And I, a racist white Southerner, I have my social club where me and the boys get together and we wear white hoods and burn crosses in black people's yards. Ah, that was the Ku Klux Klan. That's how they started. Okay, they started as a social club, a social gathering, but their intentions were dark. They were 100% bad, and they did terrible, awful things. Okay, and so today it's important that we review and remember the past so that we don't repeat it. Okay, and so this Ku Klux Klan terrible social club was bad back then, and unfortunately, kids, it is still around to this day. To this day, there are people who are part of the KKK, and they think that that's totally all right, and it's absolutely not. The KKK is terrible and awful. Luckily, though, the KKK kind of hit its peak somewhere between like the 20s and the, I want to say, 40s. And so they're no longer like this amazingly powerful force like they were at one time. At one point in time, they were a really strong power in politics, and that's not so today, thankfully. Okay, so that's the first thing we're going over today is the Ku Klux Klan. After that, we're going to talk about something that's good. We're going to talk about the Freedmen's Bureau. Okay, the Freedmen's Bureau was a government department that Lincoln had first envisioned before he died, obviously. And the Freedmen's Bureau's sole purpose would be to help rehabilitate African Americans who were once slaves and get them used to being free people. Okay, it was a great idea from Lincoln, and it was an idea that moved forward. Now, remember Andrew Johnson, who was the president after Lincoln. The dude had slaves. Okay, so he was not super sympathetic for black people, all right? In fact, he was the opposite. He was not a friend for the African American. And so, actually, he really wasn't a friend for anyone. They didn't like him in the South. They didn't like him in the North. White people didn't care for him. Black people didn't like him. So Andrew Johnson universally disliked, okay? Maybe he had good reason to drink so much. But anyway, the Freedmen's Bureau was a government department that was set up for the sole purpose of helping African American people adjust to their new lives. And so it was actually a really good thing. But because it had so much pressure against it, so people in the South, again, if you're a racist Southern person after the Civil War, are you going to be super stoked and jazzed that there's this new government department? A government, by the way, that you don't like, because the government made by the North. So there's a new government department from a government that you don't like. And this whole government department's purpose for being is to help black people, and you're a racist. So do you think that you're going to really support the Freedmen's Bureau? Nah. Okay, so the Freedmen's Bureau did not get a lot of support from a lot of the, again, racist Southerners who were around the Bureau. Okay, so the Bureau existed in the South to help these poor African American folks who were readjusting to their new life, but it got a lot of pushback from, again, this whole class of people who are still, terrible and out to get them. And so there were a lot of challenges, but the Bureau overall was definitely a force for good. Okay, and so we're going to talk about that, and then right after that, we're talking about the 14th Amendment. Okay, so after the 13th Amendment passed, the 13th Amendment passed under Lincoln, and it said, all right, y'all, in America, we no longer allow slaves. And so all these African American people, after the Union is healed and North and South are brought back together, these African American people are not slaves. It's in the Constitution. You cannot make them slaves, no matter how much you want to, you crazy South people, okay? But the Southerners still had an edge because they're like, all right, well, if these people are not slaves, they surely are not citizens of the United States because they are not as amazing as us. And so the people in the North were like, okay, we should have put that in the 13th Amendment, and we didn't. And so they went back and they put together the 14th Amendment, which specifically states that African American people and people of different skin colors and former slaves and whatnot, they're all citizens, okay? Red and yellow, black and white, we're all citizens in America, okay? Actually, that's not true. Native Americans still weren't considered citizens, but, okay, in many cases, but at least the African American people who were once slaves were now considered to be citizens, which was great, okay? In fact, Native Americans' problems didn't end until much later. But at least for the slaves, the 14th Amendment made it certain that these people were now considered citizens, which was good, okay? This is definitely a good thing. So, again, tonight, you're going to be reading the article about the KKK. You're going to be reading the article about the Freedmen's Bureau, and then you're going to be watching the video on the 14th Amendment, okay? Again, the 13th Amendment, the first new amendment in like 60 years, it opened the floodgates for number 13, 14, and 15. And so all three of those amendments are like a set. They all came together after that. Okay? All right, well, go ahead and do the Khan Academy stuff, and Mr. Barbera will be tracking your progress if you're in my class. Thank you very much. Hope you enjoyed this little senseless rambling from Mr. Rule about what you're studying in history. Thanks. Okay, so today looks like we're on week 3, day number 4. Okay, so week 3, day number 4. Yesterday we talked about universal gravitation, and then we started talking about Newton's laws. So the rules of universal gravitation state that everything is basically attracted to everything else. Okay, that's not how it works, guys, when you're asking a girl out for a high school dance. But in terms of physics, at least, everything is attracted to everything else. Okay, that's universal gravitation. We were talking about accretion disks yesterday and some of the theories that scientists have for how solar systems are formed by this universal gravitation, where these things kind of come together. We talked a little bit about how what are known as dust bunnies form on like hard surfaces, like under beds in bedrooms. If you have a hard floor in your bedroom, little clumps of dust come together. I do want to add something, though, something that I failed to mention yesterday. I think I was distracted by having my kids in the room. The gravity and universal gravity is not the only force. Okay, there are 4 forces generally thought of in physics. Gravity is one of them. Electromagnetism is the other. Okay, like things being attracted either through electrical or magnetic or both properties. And then we have 2 different forces of nuclear attraction. We have the strong nuclear force and the weak nuclear force. And so those 4 forces are kind of like the bedrock of our understanding of physics. So I didn't include that yesterday because I wanted to keep it simple. But anyway, so yesterday we're talking about that universal gravitation, and after we were done with that, we started talking about Newton's third law. Every action has an equal and opposite reaction. So let's go back, let's read a little bit, and then we're going to watch a short video about that from our friends over at the Fuse School. Okay? All right. Whoops, wrong screen. Where are we going? Oh, here we go. Okay, so yesterday we just read this, Newton's third law of motion. Okay, we talked about how the hammer, I'm going to put this little pencil down. I don't know why I'm waving it around. The hammer kind of hits the piece of wood or hits the nail. So it's exerting force down onto the nail there, as you can see on the screen. And the nail is exerting force back, stopping the hammer from moving. So, yeah. Okay, so equal but opposite. Look at that. Ice skating, something that we know nothing about in Arizona. So, equal but opposite. You may already be familiar, with examples of Newton's third law of motion. Perhaps you have watched figure skaters and have seen one skater push on the other. As a result, both skaters move, not only the skater who was pushed. The skater who was pushed, the skater who pushed is pushed back with an equal force, but in the opposite direction. The speeds with which the 2 skaters move depend on their masses. If they have the same mass, they will move at the same speed. But if one skater has a greater mass than the other, she will move backward more slowly. Although the action and reaction forces will be equal and opposite, the same force acting on a greater mass results in a smaller acceleration. Recall that this is Newton's second law of motion. Okay? So, right here, we have the action force, the woman moving in, and then the reaction force, this other woman moving in. And so if they're both pushing at the same, that would be a balanced force, and they'd go nowhere. Okay? If the girl on the right in the pink sweater is pushing hard enough, harder than the woman in the blue jacket, then the blue jacket woman and the woman in the pink sweater will both move. Okay? Also, when the woman in pink, if they're just holding hands and the woman in pink pushes the woman in blue, the woman in pink is going to go this way. She's going to go backwards, and the woman in blue is going to go backwards. So when the woman in pink pushes, they both move. Okay, it's that action-reaction. Okay? So now can you figure out how to return from your spacewalk? So yesterday we talked about running out of fuel if you were doing a spacewalk, and then your jetpack could still get you back home. But how? Okay? So, can you figure out how to return from your spacewalk now? In order to get a push back to the space station, you need to push on some object. You can remove your empty jetpack and push it away from you. In return, the jetpack will exert an equal force on you, sending you back to the safety of the space station. Okay? So again, remember, in a vacuum, things just continue going in whatever direction they're going in forever. Newton's law, objects in motion tend to stay in motion. Okay, and so if you take off that jetpack and you push against it, it's gonna, as you push forward and push the jetpack outward, you will be pushed backwards back towards the station and hopefully to get home safely. Okay. Action, reaction, and action. Newton's third law is an action all around you. When you walk, you push the ground with your feet. The ground pushes back on your feet with an equal and opposite force. You go forward when you walk because the ground is pushing you. A bird flies forward by exerting force on the air with its wings. The air pushes back on those wings with an equal force that propels the bird forward. A squid applies Newton's third law of motion to move itself through the water. The squid exerts a force on the water that it expels from its body cavity. At the same time, the water exerts an equal and opposite force on the squid, causing it to move. Figure 17, here's a squid. Okay, if you were at the Catalina Island Marine Biology Camp with us last year, you know that you know what the parts of a squid are because we all took them apart, and some of you put the squid on my face. Anyway, it's okay. It's for science. So when a squid pushes water out, the expelled water pushes back and forces the squid to move ahead to the right. The force the squid exerts on the water is the action force. Okay, and so the squid shoots the water out of its jet right there, and as a result, it pushes itself forward. It's pretty cool. All right, let's take a look here. So if you're playing volleyball like Natalie and the rest there, okay, the force on the ball with your wrist is pushing up. The force on the ball is pushing up, and then the force on the wrists is the force that the ball is pushing down. But there's an equal and opposite reaction, so the force that you're putting on the ball is much greater than the force that the ball is putting on you. So the ball has that opposite reaction, okay? Right here, force on hands, force on ball, force on ball. Okay, so in these photographs, the red arrow shows the force and the blue arrows show the reaction forces. A, we just talked about, and B, as the two players jump for the ball exerts reaction force. Excuse me, the ball exerts reaction forces on both of them, okay? So, do action and reaction forces cancel? In section 1, you learned that balanced forces, which are equal and opposite, add up to 0. In other words, balanced forces cancel out. They produce no change in motion. Then why don't the action and reaction forces in Newton's third law of motion cancel out as well? After all, they are equal and opposite. To answer this question, you have to consider the object on which the forces are acting. Look, for example, at the two volleyball players in figure 18b, so these two guys right there, okay? When they hit the ball from opposite directions, each of their hands exerts a force on the ball. If the forces are equal in strength but opposite in direction, the forces cancel out. The ball does not move either to the left or to the right. Newton's third law, however, refers to forces on two different objects. If only one player hits the ball, as shown in figure 18a, so the gal hitting the ball right there, okay, the player exerts an upward action force on the ball. In return, the ball exerts an equal but opposite downward reaction force back on her wrists. One force is on the ball, and the other is on the player. The action and reaction forces cannot be added together because they are acting on different objects. Wait, did I miss something? The action and reaction forces cannot be added together because they are acting on different objects. Forces can be added together only if they are acting on the same object. Sorry guys, I'm still getting used to like the split screen thing, so I'm trying to also gesture with my hands and read at the same time. Who knew? That's hard. Okay, so why don't action and reaction forces cancel each other out? Okay, think about that for a second, okay? Why don't action and reaction forces, like this gal, again, hitting the ball, okay? Why don't they cancel each other out? Do you know? It's because they're unbalanced, okay? These forces are unbalanced. If they were balanced, they would cancel each other out. All right, so we're going to end here talking about momentum. Then we're going to watch that video, and that's going to be it for today. So, momentum. When Newton presented his 3 laws of motion, he used 2 different words to describe moving objects. He used the word velocity, but he also wrote about something he called the quantity of motion. What is the quantity of motion? today we call quantity of motion momentum. The momentum of an object is the product of its mass and its velocity. So momentum equals mass times velocity. What is the unit of measure for momentum? Since mass is measured in kilograms and velocity is measured in meters per second, the unit of momentum is kilogram meters per second. So kg times m divided by s. Like velocity and acceleration, momentum is described by its direction as well as its quantity. Okay, so it's important to remember. So velocity, okay, is speed and direction. So speed can be going anywhere. Direction is going a certain way, but you don't know how fast. Okay, so it's important to know that velocity is speed and direction. Okay, so momentum is described by its direction and its quantity. So again, for momentum, we need to know the direction and how much are we going in that direction. The momentum of an object is the same. The momentum of an object is in the same direction as its velocity. The more momentum an object has, the harder it is to stop. Okay, if you stand in front of a moving train, it's going to take a little more than just you to stop it. Okay, if you stand in front of a moving child, you can probably stop them right in their tracks. Okay, the child does not have as much momentum as the train. Okay. You can catch a baseball moving at 20 meters per second, for example, but you cannot stop a car moving at that same speed. Why does the car have more momentum than the ball? The car has more momentum because it has greater mass. Now, that's something that you probably should have known intuitively, but there is a scientific explanation behind it. High velocity can also produce a large momentum, even when a mass is small. So there was actually this old myth that if you stood on top of the Empire State Building, like this giant building in New York that for a long time was the tallest structure around until, I don't know, until it wasn't. The old myth was that if you took a penny and you threw it off the top of the Empire State Building, you could kill someone on the bottom walking on the street because the penny would have so much, such high velocity, okay, that the momentum of that penny would strike someone and kill them, strike them right dead, boom, right there, okay? Now that's a myth because of air resistance, and because there is that air resistance, the penny actually doesn't get enough momentum to kill anyone, okay? But it could be kind of irritating and a little scary, so they usually have a net there and they say no throwing stuff over the balcony, okay? But that's the idea, okay? If you have enough velocity, even if you don't have very much mass, you can still build up a lot of momentum. A bullet shot from a rifle, for example, has large momentum. Even though it has a small mass, it travels at a high speed. All right, so that's it for our reading. Let's go ahead and watch our video. Boom, 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 boom.
There are three fundamental laws of motion, discovered by the English mathematician and scientist Sir Isaac Newton.
Okay, I gotta stop this right there. Okay, they always talk about the English mathematician Isaac Newton. I love these guys, but they are very British, okay? And so, in honor of Isaac Newton, I am drinking a very British blend. I have Earl tea. Now, if you're one of the kids watching this during the COVID lockdown, okay, and if you're getting bored of the water or whatever that you have, I recommend trying some tea. Now, if you're not a tea drinker, you know, maybe you want to start with some tea with sugar. I like my tea with a bunch of honey, so I will steep my tea bag. I'll add, I don't know, maybe 2 tablespoons of honey, and then I always add a little bit of milk or cream. Anyway, give it a shot, and that is why they always emphasize how British this guy is because Fuse School is also British.
All the way back in the 17th century. In this video, we will describe and apply Newton's third law of motion. The third law of motion states that for every action, there is an equal and opposite reaction. For example, the swimmer pushes against the pool wall with her feet and accelerates in the direction opposite to that of her push. The wall has exerted an equal and opposite force back on the swimmer. The forces are equal in magnitude or size, but opposite in direction. Forces always come in pairs, the action and reaction, and often is not clear where the second force is. Think about someone sitting on a chair. Most will spot the downward force of weight, but will not consider the force of the chair on the person. It's easier to see this reaction force if she sits on a trampoline instead. However, there are actually two pairs of forces acting here. The man's weight is balanced by the gravitational force he exerts on the Earth. He is prevented from falling towards the Earth's centre because of the upward force from the trampoline or chair, which is balanced by the force he exerts on the chair. The forces are equal in magnitude or size, but opposite in direction. Or pushing a book at constant speed across a table. The force pushing the book acts towards the right. The force of friction opposes this and acts towards the left. The arrow vectors are equal in length because the magnitude of these forces are equal. There is another pair of horizontal forces acting here. The book is trying to drag the table as it is moved to the right, but the table is kept in place due to the opposing frictional force where the table legs touch the floor. We mustn't forget the pair of vertical forces acting here as well. The weight of the book on the table and the upward reaction force of the table on the book. Consider a rocket engine in outer space. Hot gases are expelled from the back. The rocket pushes against the hot gases, and the gases exert a force on the rocket, which causes it to accelerate. At liftoff, there is another pair of forces between the rocket and the Earth, as we saw before with the chair and the book. So there are now two forces on the rocket. If, as we hope, the force from the exhaust gases is greater than the force from the Earth, its weight, we will get liftoff. Many people are familiar with the fact that a rifle recoils when fired. This recoil is the result of the action-reaction force pairs. A gunpowder explosion creates hot gases that expand outward, allowing the rifle to push forward on the bullet. Consistent with Newton's third law of motion, the bullet pushes backwards upon the rifle. The acceleration of the recoiling rifle is A, greater than the acceleration of the bullet, B, smaller than the acceleration of the bullet, or C, the same size as the acceleration of the bullet. Pause the video while you work it out. The answer is B. The force on the rifle equals the force on the bullet, yet acceleration depends on both force and mass. The bullet has a greater acceleration due to the fact it has a smaller mass. Remember, acceleration and mass are inversely proportional. For more on acceleration, watch this video. And that's how Newton's third law can be applied.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions.
And that's for you, school. You know, I'm a little surprised on their rockets. They have the NASA logo and not the European Union logo, but I guess, you know, Brexit, those British people are no longer in the European Union, or at least not for long. All right, so please continue working on that worksheet. I need to remember where it ends. You should be able to have that worksheet completely filled out, hopefully by the end of the week, if not the very beginning of next week, and then we have a little quiz to give all of you. So that's it for science today. I hope you learned something. Thanks. I have this weird split screen thing going on right now. I gotta get my head above there. We are doing math. This is group 1, week 3, day 4. And today we are talking about area of irregular shapes. All right, so I'm going to try to manage doing multiple things here on the screen. So first up, we have a problem here with this goofy looking shape, okay? And so if I had to draw the shape out without any of the inside lines, it looks like we'd have like a square here, right? And it would kind of come down like that, and then maybe over like this, okay? And then something like that. Oh, that's kind of gross. Okay, there we go. But yeah, so anyway, this shape kind of looks something a little bit like this, okay? And so today in our lesson, we're going to learn how to find the area of a weird shape like this, okay? Now, I'm actually going to be doing one of the problems from your homework. You have 10 problems in your homework today, and I'm going to be doing 2 of them with you to kind of get you started, and then the rest you have to do on your own, okay? Now, if you look right underneath here, the problem actually divides the shape into simpler shapes for us, making it a lot easier, okay? And so as you can see in the problem here, it divides my rectangle here, okay? I have another triangle here. All right, sorry, I didn't do that perfectly. And then I have my other triangle here. All right. Now, on these problems, you might look at this whole list of stuff right here that's kind of like beneath my chin there, okay? And that might really throw you off. You're like, DH equals 3 cm. What are you doing to me, Mr. Roll? This is awful, okay? But you just got to take it step by step and break it down and make it simpler for yourself so you can kind of take a look at it and work it through step by step, okay? So let's go ahead and label all of our sides. So this is side P right here. This is point P right here. Okay, this looks like point G right there. We have point C, point D, good. And then we have H right down there. Nice, okay? And I feel like we're missing something that we need here. Are we? Well, we'll find out together, okay? All right, so first up we have PG equals 3 centimeters. So from P to G, this thing here equals 3 centimeters, okay? We have G to D, which is another 3 centimeters, good, okay? Then we have C to D, which is another 3 centimeters. Nice. C to D. D to H, 3 centimeters. Okay. Cool. And then D to O. There's no O. So I think what this problem is missing here, and I'm going to interject. This is actually one of the reasons why I chose to do this first problem here. Let me zoom out a little bit so you guys can see that. Okay. There should be an O right here on this side. Okay, so I'm going to add an O right there. Okay, but D to O is another 3 centimeters. Okay, all right. So hopefully that alleviates some of that confusion. Okay, now I can look at the screen over here and I can start calculating this out. Okay, so for my square, I'm going to use blue. Okay, and so what I have to do to get the area of this whole weird looking shape, I have to get the areas of all the component parts first. Okay, so I'm going to start with the area of the square first. All right, and so since my square is 3 centimeters all around, okay, so for my square, this area right in here, okay, for my square, I can do area equals the base times the height, okay, and so my base is 3 right here, as you can see, okay, my height is another 3 right here, as you can see, so 3 centimeters times 3 centimeters equals my area. So the area of my square is going to be 3 times 3 is 9 centimeters squared. Okay, so that's the first part. 9 centimeters squared right there. Okay, now I'm going to choose green and I'm going to figure out this next triangle right here. Okay, now here's the weird thing. The picture makes it look like this part down here, okay, between D and O. Whoops. The picture makes it look like D and O is a lot shorter and D and G is a lot longer, okay? But really, the measurements tell us otherwise. And so you can't always trust the picture, especially my picture, because my picture is awful, okay? And so this is a triangle, so this green triangle area here is a triangle. And for a triangle, as you should remember, area equals 1/2 times the base times the height. So, excuse me, let's go ahead and do it. We have 1/2 times 3 times another 3, okay? And so 3 times 3, as you know, is 9. And so these two combine to give us 9. Good, okay? And then half of 9, or 1/2 times 9, if you just think to yourself, well, 1/2 of 8 is 4, okay? So 1/2 of 9 must be 4.5. I'll just write 4.5, okay? So the area of this green triangle here is 4.5, okay? We are almost done. Now I'll use some red. And so now for this last triangle, I know this side is 3. I know this side is 3. So if I want to figure out what this red part of the triangle is, again, its area for a triangle equals 1/2 times the base times the height, and they're both 3 and 3. So again, it will be exactly the same as my other triangle. Area equals 1/2 times 9. Area equals, oh, I forgot my centimeters here. 4.5 centimeters squared. I'm so sorry, I forgot my units. Okay, there we go. Okay, so that is 4.5 centimeters squared, and I also have my centimeters squared here. Okay, all right, so now I have to add up my totals, okay, because I want to get the area of the whole. I don't just want the area of one of the sides, okay? So my first area in blue was 9 centimeters squared, plus my part in green was 4.5 centimeters squared, okay? Plus my part in red, which is 4.5 centimeters squared, and I'm going to add them all up, okay? And so I got my decimal point here. 5 and 5 equals 10. 1 and 9 gives me another 10, and 4 and 4 is 8. So my final answer is 18 centimeters squared, just like that. Okay? That is actually the answer to the first problem on tonight's homework. Okay? All right, so y'all see how I did that? I just broke it down, and so we did each different part separately. Okay? All right, let's see here. What was the other problem that I wanted to do with you today? Sounds like my dogs want to get out there. You know what? Let's do number 2 together, okay? This one's a weird looking one. Yeah, let's try this, okay? All right, number 2. Okay. So a number 2, it looks like this. Okay, so we have that. We have a little bit of this. This is turning into see how poorly Mr. Roll draws class. Okay, and we have our, see, it's like right there. Okay, and we have 2 triangles that are kind of sticking out here, like that. Oh man, I totally biffed. Okay, that doesn't look great. I donked it up, I'm sorry. Anyway, something like that, okay? Ouch. Yeah, that doesn't look very, okay, pretend it looks good, okay? Life is not always perfect, kids. Okay, and so the problem, it does this, so it kind of opens it up for us there, okay? Let's see here, we have CP, C to P, FDJ, FD and J, then H, or G, I'm sorry, and H. Okay, all right, and so CF looks like it's 2 centimeters. So this is 2 centimeters right here, okay? F and D is 3 centimeters. So we have 3 centimeters, okay, right there. P and J is 2 centimeters, cool, okay. F to G is 4 centimeters. Is that right? FG4? Yeah. Perfect. J to H, we have another 4 centimeters, which makes sense because it's the same on both sides, right? And then D to J is 3 centimeters. D to J is another 3 centimeters. Okay. All right, so that's good. All right, let's break it down just like we did before. Now, this one is a little different because you see how we have these two rectangles at the top, but really these two rectangles are just like one big rectangle together, okay? And so I'm going to take those two rectangles and just combine them and make them one big rectangle, all right? And so if this side is 3 centimeters and this side is 3 centimeters, well, altogether, this whole thing up here must be 6 centimeters. That only makes sense, okay? Now, I know that that side is 6 centimeters, and this side right here is 2 centimeters, and I am going to make this big rectangle all one thing, okay? And as you know, for rectangles, area equals base times height, okay? Area is 6 centimeters times 2 centimeters, okay? So area is going to equal 12 centimeters squared. That easy, okay, nice. All right, then going on here to the triangles. Now, look at these triangles. Is there anything that they have in common? Now, if you look closely, this triangle here, right, and this triangle here, they're actually the same triangle. They're just mirrored, okay? So if I figure out one of them, I actually figure out both of them. I just have to double it, okay? So let's take a look first at this triangle right here, okay? And so as you all know, triangles, the area equals 1/2 times the base times the height, okay? So for my base here, I'm looking at 3 centimeters, cool. For my height, I'm looking at 4 centimeters, that's great. Okay? So area equals 1/2, 3 times 4 is 12. Area equals 1/2 times 12 centimeters squared, okay? And so, let me scroll down a little bit here. Area equals 6 centimeters squared, okay? That's excellent. So that's that one right there. Now again, since we know, whoops, I didn't mean to have blue. Since we know that these two squares are the same, okay, or I'm sorry, these two triangles are the same, that would mean that this triangle is also 6 centimeters squared for its area, okay? Now we just add them all up, just like we did in the first problem, okay? So we get 12 centimeters squared plus our red, our 6 centimeters squared, plus our green, 6 centimeters squared. Put them all together, okay? 6 and 6 is 12, and 12 and 12 is 24. Okay, there we go. So the answer for the area here is 24 centimeters squared. Great, that wasn't so bad, right? You guys can do this. Okay, so your homework for this evening is to take your math worksheets and do all the problems. There's only 10, okay? But you got to break each one down just like this, okay? When you're done doing the math problems, go ahead and send Mr. Barbero and myself an email with all your answers. If you want to print it out and then if you want to print it out and take a photo of it, great. If you don't have a printer, which is A-OK, I know like Allie and some other people were emailing me about that. If you don't have a printer, just go ahead and use the Notes app on your iPad. If you're one of my students, you should have that iPad available to you. Okay, use the Notes app in your iPad just like I'm doing here. And then, if you hit the little share button, okay, so right there, that little share button on your iPad, bam, okay, you ought to be able to email me from there, or you can airdrop it to maybe one of your parents' devices and email it or whatnot. Heck, if you want to take like a photo of it with a phone and just send it in to us, you can do that too, okay? So just find a way to get me the work, and remember, when you're sending in your work, kids, please make sure that you're sending it to mroll at the Vinci Tree .academy, okay? And also send it to J Barbero, for everybody's favorite Mr. Barbero, at DAVINCITREE.academy, okay? All right, that's it for math class today. Hope you have a good one. Take care and enjoy the homework. That's a terrible thing to say. Homework's not enjoyable. Well, you know what I mean. All right, have a good one. Is it recording? All right, group number 2. I got an email I'm not going to say from who. I know you were probably expecting an iPad screen for your math today, but for today and tomorrow, you're not going to get it. This is week 3, day 4, and this is also going to be for week 3, day 5. For the next 2 days, all I want you to do is catch up with group 1. So group number 2, we're doing algebra, and you guys are solving systems, which is excellent and it's advanced. But I got a message from a student in our group 2 letting me know that they didn't know how to do the group 1 stuff. And that kind of makes sense because a lot of you guys were actually advanced and maybe some of you are as young as 6th grade and you're doing this with me. And it would make sense that because you're skipping basically an entire grade or 2 of math, that you don't know how to do the area of different shapes, you don't know how to use the different formulas for circles and do different things with triangles. Maybe you're not familiar with Pythagorean theorem. So for the next 2 days, so I'm going to be inserting this little clip for Group 2's math on day 4 and day 5 of week 3. So it's a repeat if you're watching this on day 5. For these 2 days, all I want you to do is work on getting caught up. You don't have to go back and rewatch all of my lessons. In fact, please don't. You'll save some time. But I do want you to go back and follow up with all the Khan Academy links and do all the worksheets. So I am going to list all the Khan Academy links that Group 1 has already done, and I'm going to be listing all the worksheets as well. Now, I do know a couple of you, I believe Aiden and maybe Amber, have already started working on the Group 1 stuff anyway because you knew that it was a weak spot for you. So for those of you who've already started working on it, some of you are pretty much done, and that's fantastic. But just finish the rest. And for those of you who haven't started, it is going to be quite a bit of work. I estimate that it's probably going to take you the better part of 3 hours to get caught up with all the homework with Group 1. Okay, maybe a little longer, maybe a little bit shorter, depending on where you're at with some of these basic calculation skills, but that's probably how long it's going to take. So for the next 2 days, there's no new homework. It's just catching up with Group 1. Okay, please send me and Mr. Barbero an email if you have any questions. Again, all the links and all of the attached quizzes, or not quizzes, but all the attached worksheets are attached to the week 3, day 4 post under Group 2. All right. Anyway, best of luck with this, and yeah, I know you guys can do it, and I know it's not going to be that hard for most of you, but if you have any questions, again, reach out to myself or Mr. Barbero. Thanks, Group 2.